This video is made to explain our projects on wind turbine and how small wind turbine works. This three-bladed horizontal axis wind turbine includes several parts: the blades, the alternator, the tail. We are going to explain specifically how each part works.
The blades capture the kinetic energy of the wind. The wind causes them to spin through a combination of lift and drag forces. The lift force is caused by the angle of the blade. Lower pressure air builds up on the top of the airfoil, causing a net upwards force. The drag force is caused by the friction between the airfoil and the air, causing a net force in the direction of the wind. The blades cause the rotor to spin, which leads to the alternator. On our alternator, the black disc in the front contains the magnets, and you can see the copper coils in the white plate. When the black plate with the magnet spins, current is generated.
The use of tail also saves the wind turbine from destruction in high wind and making it safe because the tail will always be downwind, and the wind against the tail will turn the front of the turbine away from the wind.
The circuit breaker or brake is the final component of the wind turbine. As shown in this diagram, movement of electricity normally flows as seen demonstrated by this arrow through the cable. However, a breaker causes a little break in the connection, stopping the flow of electricity. When the switch is turned on, electricity will flow, but when it's turned off, a pivot causes a disconnection, halting all electricity. This prohibits excessive electricity production from short-circuiting a system, and can be used to stop the turbine. In our setup, we have two wires through which alternating current produced by the alternator connects to a system, and a ground wire, where you can measure voltage, prevent electrocution, and the possibility of other malfunctions. We also see a demonstration of how a breaker works. As you can see, when the breaker is turned off, the flow of electricity allows the turbine to rotate. And when the breaker is turned on, the flow of electricity stops, also halting the spinning of the turbine.